Hi, this is Mr. Roix. I'm going to take you through some problems, some of which we practice a little bit in class, on how to deal with gas stoichiometry. In particular, this is for the honors classes, dealing with problems that or reactions that do not occur at standard temperature and pressure. So you're given the reaction, ammonium sulfate can be prepared. So ammonium sulfate is actually this compound right here, NH4 2SO4, and it can be prepared or made by reacting two ammonias with one sulfuric acid. Okay, and it asks us to calculate the volume of NH3 in liters needed at 20 degrees Celsius and 25 atm to react with 150 kilograms of H2SO4. So as we talked about several times in class, you can't really do anything with grams per se in itself. You have to actually convert to moles, because when we look at a reaction, what we're really looking at is that we're looking at the mole ratio. So this is 2 moles of NH3 per, and remember, if there's nothing here, it's really 1 mole of H2SO4. So when we're solving for this, we always have to convert to moles. So the first step in solving for this problem is we need to take our kilograms of H2SO4 and we need to solve for how many grams there are of H2SO4. So the setup for this is, first thing is we need to convert kilograms to grams, because when we use the periodic table to find masses, those masses are in grams. So what we'll have is 150 kilograms. Now, whether or not you actually do this step, I wouldn't necessarily require it, but you should know that there are 1,000 grams in 1 kilogram. So 1,000 grams per 1 kilogram. So basically we're multiplying 150 by 1,000. Alright, the next step now that we have it in grams of H2SO4 is we need to convert it to moles of H2SO4. So we need to look up the periodic masses for 2 sulfurs, excuse me, 2 hydrogens, 1 sulfur, and 4 oxygen. And so 2 hydrogens would be a mass of 2 grams, 1 sulfur would be a mass of 32, that's 34, and 4 oxygens would be 64, 4 times 16, 64. So we end up with a mass of 98. Now, how do I know I put the 98 down at the bottom? Well, because the 98 is in grams, and I know I want to cancel this grams label here. So 98 grams over 1 mole of H2SO4. Now the next step is we don't want to solve for H2SO4, but we want to solve for ammonia, NH3. We want to know how many moles of ammonia. So what we need to do is we need to recognize that, based again on this balanced reaction here, that there is 1 H2SO4 per 2 NH3s. So what that allows us to do is it allows labels to cancel. So kilograms will cancel kilograms, grams will cancel grams, and moles of H2SO4 will cancel moles of H2SO4. And our answer will be in ammonia, which is what we're solving for. And if we do the math here, we get an answer of 3,061.2. And now, if we rounded this, yes, significant figures, we could actually round this off and say that it is 3.06 E, so I'll write that down here, 3.06 E to the third, and that's moles of NH3. So now we know moles of NH3, right? What we're looking to solve for is we're looking to solve for volume of NH3. The other piece of information we're given is we're given the temperature and the pressure, so we're going to use Pivner, PV is equal to nRT, and now that we know that, we're going to solve for volume, which is dividing both sides by P. So P cancels this side, and I get nRT divided by P. So if I plug my values in, so there's my number of moles of NH3. I have the gas constant 0.0821. In order to use that gas constant, I've converted our temperature from 20 degrees Celsius, which is here, added 273 to make it Kelvin, and then our pressure is already in ATM, and I go ahead and solve this, and when I solve this, I would get 2,944, which again, liters, which again, if we obey significant figures, I'm not really going to press you guys on significant figures as long as you're within reason on the test, but you would end up with an answer of 2.94 e to the third liters. That's how many liters of NH3 we'd have. And that's how you solve this problem. Look for a couple more problems like this.